This has been actually really nice since we're online like this. Sorry, my picture disappeared. There we go. We've always had snow this term, and then we have snow days, like if we even get a snow flurry, and so we end up missing like a whole week. And so this has been luxurious. I had a couple years ago, some of you might remember, we had we had no school for like 2 weeks. And so this is really nice. It's kind of like we can go at a nice mellow pace, since we won't have snow days online. I did want to mention couple things. You guys have a lab this week. It is this might be our last chance to do a playful lab. Oh no, there is another one because Sherpa New Year is in February. So a month away. You're going to get to play with plastics in your kitchen this week, and you get to take pictures. I did make a video. It's about 20 minutes. I was inspired to do this lab because, again, I teach a kids class, and we did this lab 4 years ago, and I was supposed to be doing it with the kids actually this next weekend if I had been allowed to meet with them. So I made a short video. The reason we want to watch the video is there are actually bonus questions buried in the video, so you can get 2 bonus points. You want to answer all the questions, and I'll see who does the best and stuff for answering them. So if you turned in the lab already, you can go back and watch the video. When you do the lab, it gives you suggestions for plastics. Please don't go out and buy plastics. You all have them in your house. It was a comment Sammy made on her innovation. I had considered it of making you go plastic free for 7 days, but I'm pretty sure it's not possible. I know I couldn't do it. I don't know, like there's plastic on like the overhead thing that I use. It's just everywhere in our life, which is good or bad, but you can just use different types of plastic. Some of them are not going to stretch, but just have fun. Try the best you can. And there's some post-lab questions. And when you submit it, if you did watch the video, you can add the bonus to it. And then if you already submitted it, you can email me. I think there was 1 or 2 people already did it. Next week, on Monday, we have a study set for what I'm going to go over now and a worksheet, and then we are going to review. We have a review. It's an old exam that we'll do together, and I think it's in the folder, so I will open up the folder. And then Wednesday next week, so next Wednesday is our celebration, or our so I call it call, so celebration of learning 1, and it's alkanes, alkenes, alkynes. It's all the hydrocarbons and the aromatics. And I'll answer more questions about that. If you're somebody who has a conflict on Wednesday, like Vincent and stuff like that, if you're somebody who has a conflict, a couple of people are going to take it early before class, like at 4:30. Vincent, I'm aware that you'll probably get here late, and so we can work that out. And so just talk to me on Monday. But it will post like at 6 o'clock, and you guys take it, and then you just submit it. And I will be on Zoom. So if you have questions or need help on a question, yeah. And again, I can answer more questions on Monday because I'll be more awake by then. And then in week 5, we have class presentations. So I think I had something about that in the lab from last week. All right. So aromatic. These guys were named aromatic because they had a strong aroma. The term aroma actually implies a pleasant smell. These have an awful smell. Usually I'm talking, and the room next door to us is called the bomb room because it's completely surrounded. So for 25 years, it's been right there. That's why I'm pointing there. I don't have a bomb room in my house, even though I grew up in the 70s in the 60s during the Cold War, where people actually made bomb shelters. But it's completely concrete, and it's where all the chemicals are stored. So if there's a chemical reaction unexpected, it doesn't take down the whole school. It only takes down that room. But going in there is extremely strong aroma. Melanie, because of the program she's going into, I don't know if you've done your internship yet, but there are some compounds, and these, I don't find it pleasant at all. There are some people who think it's a pleasant smell. The thing that's cool, this is actually has some cool history to it. So this is Kukuli. I think that's how you spell his name. But so benzene, they figured out the formula for benzene was C6H6. This is like 150 years ago. I don't remember, somewhere in the 1800s, I guess. And so they know they lost a whole bunch of hydrogens, right? So normally you have 6 carbons, we would have 14 hydrogens. So there must be double bonds. We can work it into a circle. And so they came up with this formula. The problem was, this is the problem, is remember that test is if you add bromine, if something has a double bond, it reacts, and the bromine, which is an orange color, will go clear. Well, if you take benzene and you add bromine, which is orange, actually I have orange now. I haven't had orange. This is exciting. Benzene, it stays orange. And so they all said, oh, how can that be? It doesn't have enough hydrogens. It's not saturated, but it doesn't react. So what this is telling us is it's unreactive. So unreactive means it doesn't have double bonds. So it's not saturated, it's not unsaturated, because unsaturated is extremely reactive. The bromine, the color's gone as soon as it touches the substance. And so they pondered about this. This was a huge mystery in chemistry. And so Kukli, the story is the myth, which is a beautiful myth, is that he had a dream one night. And the dream he had was of a snake eating its own tail. And he woke up and he said, oh, this is what's going on. And so what he said is you have the cyclo, and every other, they draw it like this, but that's not really what's happening. It's more like this. These are the 2 acceptable ways of showing it. And it is what is called a resonance. So those who are in my class, I mentioned the word resonance in Chem 104. What it is the double bonds can be like this, or they could have been next door. They could have been like that in the red position. So which is it? Are the double bonds between 1 and 2, 3 and 4, 5 and 6, or are they between 6 and 1, 2 and 3? So which way is it? And he says, well, it's both. It's halfway between each. So what you have are 1.5 bonds. Which is, how can you have that? So you have this thing here in the middle is called a pi bond. It's called a delocalized pi bond. You don't actually need to know that, but it was him making that assumption. It wasn't the snake eating pie or anything. It's just what Linus Pauling ended up calling this, is it makes this orbital that is a ring. And so there are 6, this delocalized pi bond has 6 electrons shared equally by all the carbons. So there's this ring of 6 electrons. Remember, electrons are vibrations, really, and it's shared by all 6 of those. It's extremely stable, so that's why it's not reactive. So stable doesn't really mean good in our terms with the environment, because it ends up being extremely toxic. And part of that has to do, I should have made them, but cyclohexane is not flat. Cyclohexane actually looks like this in 3 dimensions. It looks like an elephant sat on the hexagon, and so it kind of looks like a boat. Benzene, so this is benzene with the 1.5 bonds, Benzene is flat. It is exactly what it looks like on your piece of paper. It is flat. It's two-dimensional. If you could look at the molecule like kukuli is here, it would be a plane goes through every single nuclei in the center of it. And so it actually created some interesting chemistry because of the flatness of it. It fits into DNA. And so it is one of the first carcinogens that was studied in the past 100 years as they started looking at carcinogenesis, which means it causes cancer. And it's because it fits into the double helix perfectly, and just you can't get rid of it. This, because of that weird boat thing, it doesn't fit into there. It doesn't really fit into anything. So Kukuli came up with, okay, there's no double bonds. It's really this approximation, this ring of electrons, and then Linus Pauling finalized it. But anyway, that's a picture of Kukuli looking at it. Benzene rings show up in a lot of places. As you start adding stuff to it, it doesn't have as much toxicity. Benzene as pure, just benzene, is extremely toxic. It was extremely useful to use, and we ended up making lots of stuff from it, or a lot of things that had it. But let's go ahead and go through the naming, and then we can talk about these guys. When you see the pictures, and then, yeah, we'll get what these all mean, the jokes. You will see, that's what I was going to show you. Sometimes you'll see it where they show every other double bond, which is fine. And sometimes you'll see it with the ring. The ring, I think, is better because it's more realistic, but it doesn't matter. It's more realizing that if you see it drawn like this, those are not double bonds. That's a resonance structure. All right, so for naming, it's similar rules. Instead of saying cyclohexane, we say benzene. So the ending of our name on these is benzene. And we're going to number so the side groups get the lowest numbers possible. So my number 1 is going to be at the top. So this would be number 2, 3, 4. So this guy at the bottom is just 2 carbons. That's an ethyl. At number 2, that's a methyl. It's pretty easy. And then at the very top at number 1, what is that? Can anybody tell? So it's a CH with a CH3 on each side. And so this is an isopropyl. Alphabetizing, number 4 is going to go first. So we would say 4-ethyl, 1-isopropyl. Everybody's very quiet tonight. And 2-methyl. Benzene. All right. So when there's only one side group, you don't put a number because it has to be at number 1. If there's 3, you have to put the numbers so that you get the lowest numbers possible. If there are 2, you want, again, the lowest numbers. This at the top. What is that side group at the very top of our benzene here?
Isobutyl.
The other one.
Is it tert-butyl?
It is a tert-butyl. So it's a carbon with 3 CH3s around it. I don't know who said that.
Caitlin.
Caitlin. Do you know what the one at the bottom is then?
Isn't that isobutyl?
It is iso. It's the other iso.
Ethyl.
It's isopropyl.
Propyl.
So this is saying this one up here, there's 4 total carbons. So there's a carbon and then 3 more. So that's why it's a butyl, and it's a T-butyl. So it's a carbon with 3 around it. This one down here, it's a carbon and then there's a carbon on each side of it. So there's 3 total. So that's an isopropyl. These are tough questions here, but we've been at it for 3 weeks. So numbering, because it would number the same wherever we start. Where should our number 1 be? And why?
On the top, because butyl comes before propyl.
Before iso. So this
Yeah.
is number 1. This will be number 4. So I wanted to point that out. I mentioned it before, and this is again fine tuning. And this is why we do a practice on Monday, because all the naming rules are crazy. And so it's just making sure we got it, because I want everybody to do outstanding. T-butyl is hyphenated, so it actually starts with a B. Isopropyl is one word, so it actually starts with an I. Isopropyl and isobutyl both start with an I. So T-butyl goes first, and we do have to put the numbers. So 1 T-butyl, and then 4 isopropyl, and then benzene. And then I said there's 2 ways. That's what the 2 ways was. This is only going to happen if you have 2 things on the benzene. So it's only when there's 2 things, there's 3 possibilities. And we're going to see them here. The other name for this is, I'm going to write it underneath so you have the answer, is to say P, T-butyl, isopropyl. Actually, it wouldn't have a hyphen. It would be all one word, benzene. So this P, it's only used with benzene because benzene is flat. You can never use this with anything else. But the shorthand way of remembering it, write it over here in, is OMP, O-M-P. So O-M-P. They actually stand for something, and I'll go through that. But O means when they're next door to each other. So if you're 2 side groups, they can be the same, they can be different. If they're at 1 and 2, we don't actually put numbers, we say O. When they're at 1 and 3, it's an M. And when they're at 1 and 4, it's P. And this is special because it's flat at 1 and 4, they end up straight across from each other. That in a cyclohexane, again, we don't use this because it has this weird boat configuration. Like again, the elephant stepped on it, or Tyrannosaurus Rex. So O stands for ortho. That's O-R-T-H-O. There's a big agricultural chemical company called Ortho that makes a lot of nice toxic stuff that people put on theirs. M is for meta. Everybody does just use the letter O-M-P, OMP. You can write a song about that. And P is para. So para is straight across. Meta means there's 1 space in between, and ortho means next door to each other. And I don't know if these are from Greek. I don't know where these came from, but let's go ahead and try C and D. So O means that they're at 1 and 2. Again, it's only with benzene that you can leave the numbers out if you have 2 side groups. You do not have to use OMP. You just have to know what it means if I use it, like on C. So benzene, you draw your hexagon, and then you put your ring inside. So don't forget the ring. And then you can pick 1 and 2 to be anywhere you want. Just the chlorines are next door to each other. So that's what that one looks like. On the paradimethylbenzene, so you make your benzene, put your ring. I like the ring. And then para means the methyls are across from each other. So you can just put a stick like that, or you can write CH3 at the top and bottom. This one has another name. You don't need to know the other name, but I'm going to mention it. This is called Xylene. And it would get the P in front. So P xylene, I guess with a dash. Dimethylbenzene is xylene. So it's in case you run into that word somewhere. There is another one I want to mention. I'm going to put it over here because this one we run into, and this is really cool. There is one known as toluene. And for any of you, if you are into drag racing or racing and stuff, and there's often, I've had several students who were, and I guess toluene is used in drag racing for some reason. I forget why, because I've sometimes had people want to do their papers. You guys have a bigger paper at the end of the term where you pick a organic molecule, and so somebody's picked that. But the IUPAC name would be methylbenzene. So toluene is just our benzene with one methyl on it. Just a reminder, I like the rings. I usually draw the ring, or you can show it like this. That is an acceptable way of drawing it. Now, the reason I mentioned toluene, and I just have to see where I'm going on the next page. We'll wait, I'll mention that next page. But that's what toluene is in case you run into it or you've heard of it. I just put some interesting stuff here. So many of you may have heard of PAHs, stands all capital letters for polycyclic aromatic. So aromatic means they have this ring, but poly means there's multiple rings hooked up together, and then they're hydrocarbons. These are the ones that are found in smog and cigarette smoke. These are carcinogens. So burning wood, tar, oil spills, and this was straight from Wikipedia. These guys are like the classic for people who studied adverse health effects. So if you want to like initially study in cell culture and see like bad things happen to cells and bad things happen to people, like coughing and stuff. So when we had the fires back in, was that September, the beginning of, yeah, it was Labor Day weekend. And so it got our fall term pushed back a week. But we were all coughing because all that smoke had probably a lot of polycyclic aromatic hydrocarbons. Smog especially because it's industrial, and so coming from combustion of octane or different fuels, just in the combustion at the high heat, the carbons sometimes will combine in ways that have never been seen, and you get these lovely compounds. And so it goes on to talk about the poor chimney sweeps. And every time I think of that, I think of Dick Van Dyke and Mary Poppins. Why they tried to remake that with somebody other than Dick Van Dyke, I don't know. But it was actually the levels of cancer found in the chimney sweeps was astronomical. Some of the classic occupational exposures. So that's them, that it shows multiple. It's kind of hard to see in the picture, but those are extra lines, and it just means these are electrons that are shared through the whole ring, all of the 4 rings or 5 rings that are hooked together like that. The other one that's kind of crazy is creosotes. So this is like all bad news, right? Because it's the hydrocarbons. There is good news. So as you start adding things to the side, it does change their toxicity, but the ones that just combine in different ways. And again, in cigarette smoke, there's something like a couple million, thousand, trillion carcinogens in every puff. It's crazy. But creosotes are what they were using, again, found in chimney soot, but it was used as a wood preservative. And so I was talking about this earlier with my class. The light post in front of my house, like, because I've lived here for 20 years, it used to be wooden, like all light posts were wooden. And now we've actually changed, I think most of them in Gresham. It'd be hard pressed to go and find a wooden pole outside. But boats used to always be made out of wood, and you have to treat it because otherwise the salt water, the rain environment is going to destroy the wood and eat away at it. And so they found this stuff. Actually was amazing. It preserved the wood. It was great forever. And so preserving it turned out to be not so good for the environment. And so it does leach off into the environment, and it ended up in the water. And it was one of the things that hurt the habitat for not just the salmon, but a lot of other stuff. I had actually a great blessing. I had, gosh, how did I meet this lady? She was the employee of the year last year, actually, for the city of Gresham, but she does environmental talks for the schools. Oh, I had a student who worked with her, and she told me, she got me in touch with her, and she came and did a talk for 3 years in a row for my kids' class until coronavirus ended that. But she actually did this amazing talk, and there's a woman from UW in Seattle who figured out what happened to the salmon. And it turns out it's our brake pads on our cars. And so they figured out something to put on brake pads that made them work really great. And it turned out every time you use your brakes, just a wee little bit ends up on the pavement. And when it rains, that ends up in the streams. And the salmon didn't know what to do with it. The good news, the amazing news about all this stuff, there was an easy way to clean it up. And it has to do with that we made everything so clean and neat. So we put curbs on all the roads. So if you go out in the country, they don't have curbs on the road. So when the water runs off, it runs over the grass before it ends up in the stream. And it turns out Mother Nature decontaminated everything. And so that's why in Gresham and Troutdale, whenever they put in new buildings, the runoff, like here, I live right by the college, but when they repaved Kane several years ago, there's holes in the side of the pavement, the curbing, and it runs off into, it doesn't matter what kind of plant, all plants, the roots will decontaminate it, and then the water's perfectly fine. So when we started putting curbs on the road so that the runoff all went straight into the stream, that's when we started causing problems. And so they've now taken the curbs, parts of the curbs away, and putting in these rain gardens to help decontaminate. So even though we've gotten rid of the creosotes, it's actually every time you drive your car. All right. The thing that's a little scary about this, I don't know if any of you read the whole thing. This was the preservative of wood. It's also used as a meat preservative. And so I know Haley took me up on the 7-day challenge last week of going with no meat for a week. And yeah, so smoked meat, that's one of the big things. They're a class 1 carcinogen, guaranteed you will get cancer if something else doesn't get you first. So it's ending up, we're taking it in directly. All right, let's go ahead and move on. Again, these guys, when we start adding things to them, which is usually what happens, it does change their toxicity. But when they're the pure hydrocarbons, they have a lot of issues. And a lot of the issues are to our liver, because our liver is where things get detoxed. So if we take it, somehow it ends up in us. Our liver ends up trying to deal with it somehow. Headaches are a common thing. So a lot of these are solvents because they're only carbon and hydrogen. And so they were really useful, but they were hydrophobic. So back to that first lab that you all did. All right. So very first question on your study set today was addition reactions. And so I want to put that above this. Addition reaction. Does anybody remember? You can go back and look at the study set. What goes through an addition reaction?
Double or triple bond?
Yes, this is going to be a double or a triple bond. So that's the whole thing where we add bromine and look for the color change. So the orange disappears. So that's what I was mentioning at the beginning. And this is benzene. The aromatics do not do that. And so they go through the substitution reaction. And so the substitution reaction is always needs a catalyst. So a catalyst is used even when halogen is involved. and it's much slower. It's clumsier, whereas addition reactions are like before you could even snap your finger, it's already happened. And that's because they're considered saturated. I don't know if you would consider benzene saturated or unsaturated. More for you, Melanie. Whatever Dr. Javid tells you they are, if you study them in his class, go with that. They're neither really, in my opinion, because they don't have enough hydrogens to be considered saturated, but they're not unsaturated because they don't go through an addition reaction. So they put them in a class of their own. Oh, one other thing, back to the page before, is they are usually called aromatic. That's the most common name of them, which benzene is the basic building block. This term, arenes, is actually an IUPAC name for them as a family. And so if we run into that word, that's all it means. And it's sometimes just abbreviated as AR, not for argon, but for arenes. And that was Christy who just answered me, right?
Yes.
And Jeremy was my other one, and Caitlin. All right. You pick if you want to be. So back to the OMP real quick. There's actually tons of jokes with that online and all these really fun ways you can draw benzenes because they are flat and they're hexagons, and that's what the little cartoon is. All right. So the reactions. Substitution is only one. Only one thing gets added, one group, or only one piece is added. So we don't add both chlorines, and it's a swapping reaction. So it's a replacement. You don't have anywhere to add it. Double bond, there's no double bonds. So we're going to do a swapping. So benzene, and you do need the catalyst. Again, you can draw your benzene however you want, plus the chlorine. The catalyst has to be there. It will not work without it. It's still a really clumsy reaction. And what has to happen, you still have the double bonds. You don't have double bonds. You still have the ring as the chlorine goes on. There was a hydrogen. So every corner, if you look at this carbon here at the top, it has 3 bonds. So it has 1 hydrogen. So every carbon has 1 hydrogen. So this is different from when we did our cyclohexane. In a cyclohexane, every corner has room for 2 things. In benzene, there can only be 1 thing. So there is a second product, which is HCl. And I wrote it in a lighter color. So basically, a hydrogen comes off and a chlorine goes on. It could go anywhere. It doesn't matter because there was nothing on there. But it does help for a lot of students to write the other product, to recognize only 1 chlorine went on. The bond, if you draw it like this, as if it has double bonds, the bond doesn't disappear. If you draw it with rings, we'll do the next one as a ring. So toluene means we had a methyl group there. And now we're going to add chlorine with our catalyst. So there are 4 different products here. So it is because you cannot control where that chlorine goes. And so there are 4 possible answers. So this is actually this is a true bonus question. So it stays as methyl benzene, so toluene. All 4 of them still have that methyl group there. You don't change that. And since it's called toluene, when you call it toluene, the methyl gets the number 1 position. But does anybody know? Like 3 of them are pretty easy. So where would I put the chlorine? It's actually every time only 1 chlorine and then plus HCl.
On the methyl?
You could. One place you could put it is, let's draw the chlorines as green. that even going to show up? Not really. Is if you draw it on the methyl, you would show it as a zigzag like that. So you don't want to put it as like that. So this is my methyl group, and then it's attached to it. So that is one of the answers. I'm not going to name that one because it gets into something I don't want to get into today, because we'd have to name the benzene as a side group. This carbon is the main piece with a chlorine and a benzene side group. So does anybody see the other three possibilities? And there are only three.
In the circle,
Where in the circle?
in the middle, or the.
Oh no, not you can't put it in the middle, but you can put it at different places on the circle. So you could put it next door. You could put it one away, like one space in between, or you could put it straight across. So basically you could end up with a 1-2, a 1-3, or a 1-4. Why is there no 1-5?
Because it's
Or
the
one-
ethyl.
Or 1-6. So there wouldn't be a 1-5 or a 1-6.
Because it would just be the same. Like it would.
Yeah,
you would just go the other
1-5
direction.
would be this. It just means you numbered in the wrong direction. Yeah, or 1-6. So they're either next door to each other, one spot apart, or straight across from each other. The answer to that is completely wrong. So you could not do this. If it's there, you cannot put the chlorine and the methyl at the same position. So, and it has to do with this carbon would have 5 bonds. And so that's just not going to happen. So if you drew it, put a big X through it. This guy here would be O, M, and P. So it's something that's really cool with benzenes, and because of its flat, so you would end up with orthochlorotoluene, metachlorotoluene, and parachlorotoluene. Toluene again is just the name for methylbenzene. It's just a lot easier to write than writing the whole methylbenzene out. All right, there are some really cool things you can do with benzene, which is you can add things other than just say chlorine or hydrogen. We can't add hydrogen because there's no double bonds to break, but you can add more carbons like to the side. So we start with benzene, and this would be the chlorine is coming off here. So this is carbon 1, 2, and then our chlorine's coming off there, right? And if you want, you can write your carbons in. So that's a carbon, and that's a carbon. And it's specifically this chlorine that allows it to happen. There will be a catalyst, as I mentioned there. So it's aluminum chloride that we show the catalyst on the arrow. It just means it's there. You always need a catalyst for these to work. But I'm going to draw my hydrogen here. This hydrogen and chlorine are going to end up as one of our products. And our benzene, still a benzene, it's going to have the ethyl group on it. So the chlorine is extremely reactive, and it wants to be with the hydrogen because it gets more electrons. It's a more polar bond for it. And so it pulls that hydrogen off, and in the process attaches the ethyl group. So this would be ethylbenzene. You could do that with any size group. The cool reaction is this one, which is called nitration. And H2so4, they say it's used to activate. We can think of it as a catalyst, but it's a little bit more. And so that's why it's in parentheses there. But what happens is the hydrogen comes off the benzene. And you'll see where I'm going with this in a minute. And you end up with, so we have HNO3. We'll show the H2SO4 on the line. H2O is going to be one of our products. So we can change our color here. So there's the H. Here's an H for the H2O, and one of the O's comes off. So you're going to end up, you still have the benzene, but what I was trying to show is you end up with a new group on there, which is an NO2. So you lost the H and one of the oxygens, and this is called Nitro Benzene. So an NO2 group is called a nitro group. That nitrogen has a double bonded oxygen, another oxygen. And why that is cool, yeah, look, more good news about these guys in cancer, right? Is if you had a toluene like up there, and you reacted with nitro a couple of times, you keep reacting it, you can get something, and if you want, we can draw it down here, which is called tri-nitro toluene. And I'm pretty sure you've all heard of it, whether you realize you have or not, because if you pull the initials out, it is TNT. And nitro groups are highly explosive. And so it was how, so I have to think, TNT, was that the one that was made by Nobel? And that's how he ended up with so much money in the Nobel Peace Prizes. But anyway, so if you have toluene, so you have the methyl group there, and then you put NO2s at, like, they usually like to be at every other position. Just real quick, sometimes when they write NO2s all the way over on one side, they write it backwards, same like methyls and an NO2. The NO2s can end up really at any position, they just can't end up at the same place, but you get trinitotoluene or TNT. Nitro is added to like cellulose, that's where the nitro groups are explosive. So nitros are explosive. What is the one that's given us the heart medication? My brain is like not here today. But I mention that because some people, nitroglycerin is another one. So nitroglycerin, that's actually the one that Nobel figured out how to make it, because they couldn't keep it stable. And then he figured out how to make it a more stable form for munitions, and yeah. And then he ended up having heart issues, and so he couldn't even take his own thing. But nitroglycerin is used for people with palpitations and heart issues. It's also an explosive that's used. So kind of a cool topic. All right, questions. So I'm going to pause. You guys can take a 5-minute break if you want, or you can try some of this page, which is just more practice, or you can giggle at the jokes at the bottom, and then we'll go over it, and we'll be done. All right, so hopefully you're back, or if not, I'm back. So benzene, so again, benzene, you can draw it like this, where it looks like it has double bonds, but just realize it doesn't, or you can just draw the circle. Just remember to show that. Ortho means next door to each other, or 1, 2. And our celebration again next Wednesday. You can use notes. There's no way I can control that, so everybody might as well have notes. But it is, if you study and you just go back and redo your study sets, you'll probably find you don't need them. It's nice to have them as a backup. And so it's methyl. So you can draw it like that, or you can draw the CH3s, the methyl group. That's it. All right, toluene means we draw our benzene, we draw our methyl. So again, this is methylbenzene. The methyl gets number 1 no matter what when you name it as toluene. And then you can number either direction. I'm just going to go 1, 2, 3, 4, So at number 3 is a nitro, so NO2 is what nitro means. And at number 4 is isobutyl. So isobutyl looks like that if you do it as zigzags. One actually shows up on your worksheet tonight. So peace sign without the bend is isopropyl. And if you get the kink, so I had students and they said it's like an elbow if you're holding out your peace sign with your elbow. So that extra elbow, it's butyl because there's 1, 2, 3, 4 carbons. So that's what an isobutyl looks like. And again, that's why on Monday we will do practice. So it will get posted. There's the study set and worksheet with these guys, and then we'll do practice. And I will actually give time. So during the lecture, we'll do the study set, which is pretty straightforward. And then I will give you time to like work on the practice test or practice celebration. And then I'll go over a page and I'll give you another 10 minutes to try some of it. And I'll pause recording and stuff, and I'll record it, and then you can go back and print it again and work on that. And I will have office hours Saturdays, so if you have questions on the lab, so Saturday morning, but it's I know 1 or 2 people have already done it, and it's pretty straightforward. And again, I made a video like 20 minutes and it has some bonus questions in it, so if you want a bonus point or 2. All right, there are 2 ways to name this one. If this is a methyl, and what is this side group here? Well, it has 1, 2, 3, 4 carbons.
Butyl.
It is not tert-butyl. It is a butyl. This is sec-butyl.
Iso.
No, this one's
Sec-butyl.
sec. This is sec-butyl. So all 4 in a row, like you can make a line straight through them. In iso, you have this peace sign. You have this fork that happens. So this one up here is isobutyl. This is sec-butyl. And we'll get more practice with that on Monday. If you name it as benzene, so I'm going to give you 2 different names for this one. If you name it as benzene, then the sec-butyl goes first. It will be at 1. So you would say 1 sec-butyl. Actually, I could give you multiple names for this. 3 methyl. So you would number counterclockwise. So this would be your 3. However, methylbenzene is toluene. So if you name it as toluene, the methyl is always number 1. And so the sec-butyl would be at number 3. So you would have 3 sec-butyl, toluene. But there's another way. Does anybody see the other way? So it's really simple. It's a simple modification. Instead of saying the 3, these are at 1 and 3. And so this would be M. Instead of 3, you would just say M sec-butyl. Sec-butyl, by the way, is hyphenated. So it starts with a B and then toluene. So since they're in the 1 and 3 position, we can use meta. Again, the ortho-meta para is only used with benzenes or aromatics. All right, this one, this long side group.
On the last one, does it matter which way we name it?
No, so thank you for asking that, Jeremy. If I ask you to name it, just pick one way and go with it. If I sometimes if I have one like that, I'll have a bonus point. Hey, can you give another name? So always go with the one that you're confident with. But yeah, the OMP, it's more if I use it. So I could use any of those names that you would be able to draw it up there. All right, this one, this is my number 1, 2, 3, 4, 5, 6. This is a side group. And so I said I didn't want to go here on that previous page, but we are on this one. So this is hexane for the 1, 2, 3, 4, 5, 6. This is a bromo. And what is sticking off here at number 6, when benzene is a side group, that is what its name is phenyl. So not like the spice phenyl, but it's YL is saying it's a benzene side group. So it starts with a P, so the bromo gets the number 1 position because alphabetically it comes before. Since they're at the 2 ends, the alphabet determines that. So we'd have 1 bromo, 6 phenyl hexane. And it is because the 6 carbon with a bromine, we don't know how to name that as a side group. So it has to be the main chain, and the benzene ring as a side group, that's what it's called. So again, that's the 6 phenyl is, it's a side group. All right, reactions. So again, toluene is a methyl on a benzene. We're adding chlorine. So you still have the methyl. Nothing changes about the carbons. What's going to happen is, and if you want, it's where the colors can be fun. A hydrogen somewhere is going to come off. And so you're going to get HCl as a product. So again, that's what it means to be a substitution. It's a switcheroo. So some kind of swapping is happening, and the chlorine would go on here. So chlorine should be, sorry. The chlorine can end up at O, M, or P. So you can do, we did this one already. You can have the chlorine at O, at M, or at P, or on the, so orthochlorotoluene, metachlorotoluene, parachlorotoluene, and there is actually one more choice. So, question I've been waiting for, but everybody's tired, is, do you have to show all of them? To get full credit, yes. To get part credit, show one, because if you show things that are not products, you also will lose part credit, but there is part credit. That's why it's show your work. And so you get a mix on these. Addition reactions, the ones that were on your study set, there's one answer. Substitution, there's always multiple answers. All right, and then xylene. So does yours have the P in front of it like mine does? If not, I have to tell you what type of xylene, because xylene means there's 2 methyls. Xylene is a dimethylbenzene, and those methyls could be ortho, meta, or para. So I have to tell you, paraxylene is what we're going to do. So dimethylbenzene is what xylene is. And so we're going to put the methyls across from each other. And again, you can put it any way. It's just however you turn it. And we're adding methyl chloride. So we can put the H here is going to react with the chlorine. And so we will get HCl again. So there's always 2 products on these. And we'll still have our benzene. We'll still have the methyls on there. It's just we're now going to have another methyl. And you can put that methyl not at 1 and 4. Wherever you put it, it's the same thing. There's only one answer here. Actually, there is a second answer. No, I don't think you can give it on the methyl. So naming the products. Again, these guys were chlorotoluenes. So O-chlorotoluene, M-chlorotoluene, parachlorotoluene. This last one we did would be, you would no longer name it as a xylene. We would name it as a 1,2,4 trimethylbenzene. That's kind of a weird thing. If you named it as a methylxylene, I would not mark it wrong, but I'm pretty sure they don't. Those are like minor things. And then you can enjoy the joke about orthodox, paradox, and metaphysicians. But that's all I got. Unless there's a question, I'm going to stop recording.